Hello DSST students, welcome back to 6.2. Today we're going to be learning about drawing those atomic models that we saw way back on 1.2 for the first time. Yesterday we learned how to use the periodic table to calculate protons, neutrons, and electrons, and today we're actually going to be taking it one step further to draw our own models. Now, in this format online, it's not as easy to draw these models, so we'll be doing a lot more analysis than we typically would if you were in my classroom with me. So you should have already finished the do now, which is review. You should have done the explore section, reviewing the definitions of electron shells, which are these circles outside of the nucleus, and valence electrons, which are the electrons on the shell furthest from the nucleus. The two key vocabulary that you saw last week, but we wanted to make sure you understood today. Then you should have completed the PhET. You should have learned how many electrons fit on the first and second electron shell. And then you should have analyzed two models of lithium and beryllium. These models tell you how many electron shells there are and how many valence electrons there are. If you compared them to the actual periodic table, you should have noticed a very important pattern. Let's dive in. So, we're going to go through notes here together today. First, a Bohr model is a representation of an atom including all of its electrons. You'll see in a moment there's a lot of different types of Bohr models that scientists draw, but they all look something like this. Our nucleus on this Bohr model is highlighted in green, and it includes the symbol for carbon, telling us it's a carbon atom. Then you'll notice there's electron shells outside of the nucleus, and you'll notice the number of electrons on those shells. Now, carbon has 6 electrons. So we'll notice that here it has 2 electrons on the first electron shell, the one closest to the nucleus, and then it has 4 electrons around the second electron shell. So the electron shell itself is the outside part of an atom that contains electrons. Now, like a lot of things in chemistry, this is a slight oversimplification. It is accurate, but as you'll learn in high school chemistry, there's things called orbitals, S, P, D, and F orbitals, and you'll learn exactly how electrons fill those. The electron shell is slightly a simplification, but it's really a useful simplification in order to understand how elements and atoms work. Last, the valence electron is the electrons on the shell furthest away from the nucleus. So in this carbon atom, for example, we have 1, 2, 3, 4 valence electrons, even though we have 6 total electrons. All right. So some rules for drawing Bohr models. First, electrons are always placed on the electron shell closest to the nucleus first. So if I have 6 electrons, I'm going to start by drawing this one and that one, filling up that first shell, but I still have 4 leftover electrons, so I would go to the next electron shell and I'd place 1, 2, 3, 4 on this second electron shell. Number 2, when the shell's full, move outwards to the next shell. The first shell fits 2 electrons, the second shell fits 8 electrons, and the third shell fits 8 electrons. After the third shell, things get slightly more complicated, like I said, so we're going to stick to the first 3 shells for now in terms of figuring out the number of electrons it has. Okay, let's move back to our guided practice. Let's move back to our shortcut. Now, you can always draw a Bohr model. It's a useful tool to figure out how many electron shells an atom has and how many valence electrons an element has. So I could tell you, go ahead and draw a carbon Bohr model to figure out how many valence electrons and electron shells. However, that takes a long time. There is a shortcut. The number of valence electrons in a neutral atom is equal to its group number. So for example, a 7A element has 7 valence electrons. The number of electron shells is equal to its period number. So something in the third period has 3 electron shells. So we can use those shortcuts also to help simplify our time. Now I do want to show you there's a lot of different examples that we could see here. We'll see Bohr models that look like this one of carbon, this one of carbon, and this one of carbon. Now, even though they look different, they all contain the same information. Tells you it's carbon here, has 2 valence electrons in the first shell, 4 valence electrons in the second shell. This one doesn't tell you it's carbon, but it tells you it has 6 protons, so you could use the periodic table to see that it's carbon. It tells you how many neutrons it has. And then for these electron shells, they look like they filled them in slightly differently. Still has 2 on the first electron shell in light purple, and then 4 on the second electron shell, which they put here in dark purple. The third one is very similar to both of the other ones. The nucleus here in the middle, the first electron shell with 2, the second electron shell with 4. So we'll see all different types of Bohr models today and in the future, and we should know that they represent the same thing. Let's get started. So open up your periodic table. Number 1, analyze the Bohr model on the right. Fill out the information using the Bohr model. So number of protons, number of neutrons, and number of electrons. Okay, we can just count these up. So protons, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, protons are positive, so I knew those were the ones with the positive symbols in the nucleus. Neutrons are neutral, so they must be the unshaded ones in the nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neutrons. And then my electrons are negative, and they're on the electron shells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons. What element does this Bohr model represent? Well, remember from yesterday, we can go back to our periodic table. It has 10 protons, so we know that it must be element number 10, which is neon. This element is neon. How many electron shells does this atom have? Now be careful. When this question is asked of you, it's asking how many electron shells does this atom have that actually contain electrons? So if we look at our model, this is the nucleus. Then we have 1, 2 electron shells with electrons on them. And there's a third shell, but there's no electrons on this one. So it has 2 electron shells. Remember, that's how many electron shells actually have electrons on them. How many valence electrons does this atom have? Okay, so we're going to start at the nucleus. We're going to go to the outermost ring with electrons. So that's the second one. And we'll count up all of the electrons. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 valence electrons. Now, let's go back and double check our work with our shortcut. So remember, on the periodic table, okay, we're looking at neon, which is right here. The number of electron shells should be equal to its period number. Well, period is a row, and neon is in the second row, so it does have 2 electron shells. It's also in group 8A, which means it has 8 valence electrons. Awesome. So far, so good. I do want to point out that shortcut there is only one limitation. It does not apply for these elements in the middle here called transition metals, so you will not see me ask any questions about them. It also does not apply to helium. And that's because helium has 2 valence electrons, and the first shell only holds 2 valence electrons, whereas the later ones hold 8, which is why they are all 8A. So that's a small caveat. I will try not to confuse you with that. I don't want to trip anybody up. I want to keep it as simple as possible. Okay, number 2. A student created a Bohr model of silicon incorrectly. Analyze their Bohr model to find their mistake and explain what they did wrong. So silicon is 14. Okay, so let's look at their Bohr model. Well, they said 14 protons, 14 neutrons, 14 electrons. That's correct. Uh-oh, I already see their problem. Look at how they filled out their Bohr model. They put 1, 2, 3, 4, 5, 6, 7, 8 electrons on the first shell. The first shell only holds 2 electrons. They drew 8. That is a mistake, and that'll throw you off because it makes this incorrect. What is the correct number of valence electrons this atom should have? Well, there's 2 ways to figure this out. Let's take the easiest way, which is to open back up our periodic table, find silicon, and see that it is in group 4A, which means it should have 4 valence electrons. We could also fix that by drawing it out the correct way, but in this format, we're going to try to reduce the number of times you're actually having to draw out models. All right, without drawing out a model, use the periodic table to calculate the information below. So argon, we need to figure out protons, electrons, valence electrons, and electron shells. So argon is here, 18. So that's its atomic number. I see that it is in group 8A, and it is in 1, 2, 3. It's in the third period. So let's fill out that information. Atomic number 18, which means it has 18 protons. Should also have 18 total electrons, like we remember from last one. Number of valence electrons. It's in group 8A, so it should have 8 valence electrons. And electron shells. It's in the third period, so it has 3 electron shells. This second one, wait, it doesn't tell me any information. It only tells me the valence electrons and electron shells. Well, we have to go backwards and figure it out. So 5 valence electrons, so it's going to be somewhere in 5A, and 2 electron shells, so it should be in the second period. Well, be careful here. If you think it's phosphorus, you're wrong. Phosphorus is in the third period, so it has 3 electron shells. So first period, second period, and in group 5A, that is nitrogen, element number 7. Nitrogen, 7 protons, 7 electrons, and it has 5 valence electrons and 2 electron shells. All right, last practice problem we're going to be doing here together. Draw a model of boron by adding the electrons from the key onto here. Okay, so boron is here, okay, has atomic number of 5, which means it should have 5 protons, which means it should have 5 electrons. So let's start by drawing out. So 5 total electrons. We have to drag our first 2 onto our Bohr model. 1, 2, and I'm putting those in the first shell, but now the first shell's full. So I have 3 more electrons I have to do something with. So let's move those to the next shell. 1, 2, and 3. Now, it's okay however you want to space these out. Some teachers have some specific requirements, and you'll see later in college and stuff, it'll be easier to draw them certain ways. For now, they just need to be dragged onto the correct one. So, quick double check. It currently has 1, 2 electron shells with electrons on them, and it currently has 1, 2, 3 valence electrons. Let's go back to our periodic table. Boron. It's in the second period. It's in the second row, so it should have 2 electron shells. And it's in group 3A, so it should have 3 valence electrons. So 2 electron shells, 3 valence electrons. We did our work correctly. I love using the periodic table as a quick double check when I'm done with my work to make sure I've done it correctly. All right, go ahead and move on to the check for understanding. Pause the video. We'll go through it in a moment. All right, at this point, you should be ready to go. If you need some more time, make sure you pause the video. All right, first one, it has 2 protons, 2 neutrons, and 2 electrons. I knew the protons were in red because they had the positive symbols in them. This represents helium. I knew that because its atomic number was 2. It has 1 electron shell, and there are 2 valence electrons. 1, 2 valence electrons. Next one, the first one was bromine, atomic number of 35. 35 protons, 35 electrons, 7 valence electrons, and 4 electron shells. Last but not least was indium, In, atomic number of 53. 53 protons, 53 electrons. It has 3 valence electrons and 5 electron shells. You are ready to move on to independent practice and today's mastery check. Like always, please make sure you're checking with your teachers if you're feeling confused or need help. And have a lovely day. I'll see you again next week.